One second. Also, another minute, 1 second. Okay, can everybody hear me?
Yes.
Yes? Okay, great. Okay, hello everyone. I hope everyone can see me okay. My name is David Berger. I'm a software engineer at Ex Libris, which is part of Clarivate in the ANG sector. And I wanted to give a presentation today about applied AI, about using AI in practice. And I wanted to specifically focus on a sub part of AI called natural language processing. I'm just setting up my screen now. Okay, can everyone see the presentation?
Yes.
Okay, excellent. Thank you so much. So I feel like AI obviously is something everybody wants to learn about, but a lot of people, at least for me, it kind of like, came out after, I finished my college degree, and a lot of people know bits and parts of AI, and they would like to learn more. And so before I dive into NLP, I wanted to first just give a very quick refresher, an explanation what is AI and how it works, just to make the same language for everybody. Then we have a short review activity to understand generally when we want to use AI, when we don't want to use AI. And then after we are all caught up, everyone is on the same page of our terminology and the general concepts in AI, we will then dive into NLP. NLP stands for Natural Language Processing. And I chose this topic in AI because it's the one I know best, but also because it is a topic which is very relevant. ChatGPT and all of these large language models, they're the heart of this topic. But also, it's a topic which, if we use NLP as an example, we can understand and learn about AI in general. The same issues we face when we will build our own NLP pipeline, basically any software engineer will face when building any AI pipeline, more or less. There's some things in this lecture I wanted to be clear and understandable. So here and there's a tiny bit of imprecise cataloging of terms or things you could disagree about. So I'll try to mention that when we go. So what is AI and will it replace me? 4 terms. AI is an extremely general term, which means any machine which does something like a human. Nowadays, that has totally lost meaning because every company wants to brand themselves as an AI company, and it really doesn't have a clear definition. Machine learning is much more defined. Machine learning means I have a certain amount of data, and I want to statistically look at all this data and then try to learn something from this data. Deep learning is like machine learning, but like 400 times more. I have my data, I want to learn something, and I also really want to guess properly. So I will run again and again and again and again and again and again on my data until I can really clarify something really cool. That's called deep learning. Data science is a term which is used a lot to mean anything having to do with data. Because AI is based on data, a lot of things in data science are also with AI, but not necessarily. You can have someone who is a data analyst who has no college degree, and you could have someone who is a data analyst who has a PhD or more. So data science is a very big term also, which is used in many different contexts. This slide is not perfectly exact, but it gives a good idea. AI is a general term, so in many ways, natural language processing, which includes a lot of things, could be just called AI in general. AI agents, although obviously they use a lot of deep technologies, it's a general term which includes a lot of different technologies and a lot of different strategies and ecosystems. Machine learning is usually more closely associated with any sort of recommendation system or anomaly detection will always be more machine learning because, again, it has to do with my data and then trying to see if something matches my data or doesn't match my data. Deep learning is kind of like the more intense things of AI, where we do something a lot of times until we get it perfect. We'll learn about neural networks in general, but things like speech recognition or image recognition, which is really kind of like doing something a lot of times until we get it perfect, those are usually based on deep learning. So now I don't know what everyone is and what you guys do in your jobs. I'd be interested to hear if you guys want to write in the chat while I'm talking if you want, but no pressure. I'm going to look at the chat during the break in the middle of the lecture. I wanted to just talk about a little bit the difference between a software engineer and an AI developer or a data scientist. So a lot of people nowadays, at least for me, I'm a software engineer, but whenever ChatGPT comes out and we think, oh, AI is taking over, so a lot of people say, well, maybe I should just move to be a data scientist instead. So what does it mean? A software engineer is someone who deals with a lot of logical problems, who deals with customers and business, real-time, real-world constraints, who has to be flexible, is constantly asking himself or herself, should I do this? Should I not do this? Is it worth to solve this bug? Is it not? There's a lot of design here. A data scientist works in a totally different world. They might have a similar background, and usually their first degree was in computer science, even if they had a second degree in data science. But a data scientist deals with a lot of mathematics, like proper mathematics, not just logic. They have a lot of research. They have very long-term projects where they're narrowing out little niches and details. They always care about their accuracy, and they don't necessarily deal with customers or real-world things. So they can work a long time on a very abstract problem or project, which will impact a lot of people, but they can't really say, hey, I built that. So a lot of times a person, if they study software development and they think, oh, I want to know about AI, the answer is not always to be a data scientist. A lot of us know that nowadays AI is basically putting a lot of people kind of like out of jobs. So much so that you could see that we're reducing the need for people to do so many jobs in our market. Where did I get this from? What do you guys think? Who made this quote? Can anyone guess? ChatGPT. Even making a slideshow presentation, obviously now with ChatGPT is you could do everything. So the question a lot of people have in the software world is, okay, how much will AI replace me? So I wanted to just relate to this in parentheses. This is not the point of the lecture here. Here is a quote from Dario a year ago, who's the CEO of Anthropic, which is a very big AI company, where basically he, as essentially a researcher, even though his company does other things, he's saying we're going to replace basically all software engineers, like 90% of them in a year from now. So what happens when an AI researcher says this? Someone who has a lot of money reads that in the newspaper. He says, oh, I want to invest my money in Anthropic. Where does the money go now? Because of this quote in the newspaper, who gets the money? You guys can answer. You also don't have to answer. Obviously, this money goes to Anthropic, right? Meaning there's an imprecision always in the AI researchers' claims that they're taking over everything, because they always want to say they're taking over a lot, so that more people will invest in them, and then they'll really be able to take over a lot. So whenever reading a lot of things in the news or in all these websites and different channels of social media, we just always have to understand who's speaking and what he is really talking about and what is his motive in saying this. That was a side point. At any rate, I assume most people here are going to stay in the software engineering world, but they really want to understand about the AI world. Now I want to talk about a little more practically AI integration. So we have a lot of parts of our software system. We have front end, we have back end, we have database, we have user interface, we have customer, we have DevOps. And even if every single one of them
I made a lot greater with AI, and I made, let's say, instead of needing 5 people on front end, I need only 1 person. Let's say instead of needing 10 people in my customer, I only need 3. But someone still has to wrap all these parts together. And so the claim that AI is going to totally take over the job of every software engineer or anyone who works in technology, any product owner or a manager, it's a very hard claim to make because there's someone who needs to develop the AI, but someone also has to use it and integrate it all. Obviously, we have to know how to use it well, but it's hard to say that everyone is going to lose their job to AI. Another concept, I'm sorry, here and there are Hebrew words, but I'm speaking in English. I hope it's okay. This was made for Israelis from Jerusalem in Israel. Another concept in economy, which is I think very relevant here, and we'll use this parable as we go through our session. Let's say we have Rob in the red book, in the red shirt, and John in the gray shirt. Rob sells his hot dogs, and John sells ketchup. So let's say Rob has a big breakthrough and sells a ton of hot dogs. If now people only sold 100 hot dogs, so tomorrow people are now selling 100,000 hot dogs. So what's going to happen to ketchup? Ketchup will also raise. Why is that? Because you need to have ketchup with your hot dog. You're not going to need a hot dog without ketchup. So a lot of people use this parable to describe AI and software engineers. Because the more AI grows, it's true that it's maybe like kind of like, I don't want to say this, but a cooler product in some ways than software, or in many ways strong or more powerful, or will impact the market even more, all these other things. You always need somebody to put ketchup on your AI to make sure your AI tastes good and feels good and will digest well and will be presented well, and the customer will want to eat the hot dog, right? So in that way, a lot of times, a lot of people will say that even though AI is taking over the market, with AI rising is also software. That was an introduction to what is AI and will it replace me. And now, when do we actually use it and when do we not? I want to talk about 3 categories. The first one is Gen AI. So a lot of people think that Gen AI, which basically means when ChatGPT is able to tell you about something and talk like it's a human, they think that ChatGPT is basically a person with a brain. Now, it's true ChatGPT is really smart, and there are a lot of similarities to how our brain works. And neural networks is a fascinating interplay between biology, neuroscience, and software engineering. But it could be more accurate of a parable than a brain is really a monkey. Why? Because a monkey sees something and a monkey does something. I want to give an example of how basically Gen AI works. Now, I live in Israel. There is someone in Israel named Bibi. Bibi is the Prime Minister of Israel. He is very hotly debated in the Israeli, world. Okay, especially in the past 2 years. If everyone knows the news, there's a lot of things going on. I asked my Gen AI machine, "What do you think about Bibi? You like him or you don't?" And it could bring me a list of things. I know some of them are in Hebrew, where basically all these different things are different newspapers. Some of them think Bibi is really good. He is a leader. And some people think he is awful. He is causing destruction. So how is ChatGPT going to react when I say that? So nowadays, probably ChatGPT has become politically correct and they are able to edit it. Someone manually edit it so that it doesn't, insult anyone because then they'll lose customers. But the AI, simply what it does, it looks at sources and it gives you a summary of what the sources say, and no more than that. There's a lot more details after that manually to make sure we can train it properly and guide it and fix a lot of things, but that is the core of its algorithm. And therefore, general takeaways are, when we use Gen AI, we always have to understand the context and what you're speaking, what the LLM knows and what he doesn't know. You have to always understand that you can give the same exact input today as you do tomorrow, the same exact input, but tomorrow you might get different results. The results are always changing because the context, even the general context that the LLM is based on, and the general knowledge is always changing. And therefore, there is always an inaccuracy percentage. And therefore, if I need to rely on an output of an LLM to give me something which is 100% accurate or 100% deterministic, like if it's like a real-time system or if it's a life and death or something like that, I need to wrap my algorithm in verification to understand, did it do it or did it not do it? And I always have to have checks in place to make sure that nothing, happens with this inaccuracy percentage. I want to talk about machine learning. let's say I have Cookie Monster, and I want to teach Cookie Monster, is something a cookie or not? So one approach to do that is to give him a cookie and ask him, is this a cookie or not? He says yes or no. Is this a cookie? Is this carrot? Yes or no? And that's kind of the general way people think of how to teach a machine. Another way to teach Cookie Monster is give him all the cookies. And you give him a ton of cookies, even like 1,000,000 cookies or 100,000,000 cookies or 1,000,000,000 cookies. And you have to tag each cookie with a little note that says this is a cookie and this is not a cookie. This is what supervised and unsupervised learning is. Supervised learning is I'm having a dialogue with the machine. He is constantly giving me a guess, and I'm telling him yes or no, yes or no. And in some ways, with less data, you can train him in a more sophisticated way, but it takes a lot of resources for me to train him. Whereas unsupervised learning is I just give him huge amounts of data, obscene amounts of data, which is available now, and I don't have to train him. I don't invest in him. I don't do anything. The machine does it by itself. The machine learns by itself. And this obviously is a huge field in of itself called information retrieval, or RAG, which is a way of augmenting grammar, which is basically the very non-trivial way, how do we tell the AI about data? So in summary, our data sets, when we're training our AI, they have to be huge and they have to be clean. So the bigger the model is, the bigger the data set is, the more data we have, the better and more accurate the results are. However, if the data set is big and includes a lot of inaccurate things in the data, or things which are a lot of outliers, and I don't have a way of verifying the data before I give it to the machine, so then I'll confuse the machine. The third topic is neural networks. This is a lot of math. I don't remember all my math from my college degree, but basically a neural network, the general, very naive understanding of a neural network is I have a lot of different types of inputs. I have weights, which means how much I care about this input or not. I have some sort of heavy functions to understand how can I compute this to yes or no, to a Boolean activation function. Then I get the machine's answer, is it or is it not? In real terminology, that means I have, let's say, a picture, and I want to see is this a number 3 or not? All the different pixels are different x's, they're different inputs. I want to know how much do I care about each pixel and its color. I have all this math in the middle, which tells me, then summing this all up, my answer. It has matrix multiplication here. It has a sigmoid, which is a very heavy calculation here. And this whole entire thing relies on backpropagation to do this again and again, which relies on derivatives, which is very heavy for a machine and a human. What does this mean? So it means basically a lot of very heavy math. Now, pretty soon when they came out with neural networks, which is a long time ago, they realized, well, this is cool, but it would be really cool if we had a lot of layers in our neural networks. That can really get us real results, because just one neural network doesn't teach me so much. So they said, instead of doing all this math one time, we have to do it like 100 times, or 100 times, 100 times. This obviously is very heavy calculations on our machines. It's very slow, and it costs a lot of money to do such a thing. And therefore, about I don't know how long, 10 years ago or 20 years ago, I don't remember, but they had an AI winter, which is a terminology in history to mean that basically we had all this AI innovation and all these algorithms for neural networks and layered neural networks, but we don't have enough machines to do them. So AI just kind of shut down and didn't come to production because there weren't enough powerful machines. But then when ChatGPT came around, it's because we had strong enough machines to basically do all these calculations quickly enough. How does this impact me as someone who wants to integrate this into my technology? Whenever I want to use cool AI, I have to realize it's heavy, it's slow, and it's expensive. And therefore, in summary, I have to always be thinking to myself, if I want to use something, is this worth it? Am I giving it the right data? Is it clean enough? Do I realize that it could be sometimes inaccurate and changing? And do I realize that using the AI is expensive and I might not want to use the AI? If I'm a software engineer and I'm doing something which is a deterministic, easy thing to do, it's very possible I want to tell my AI to write code for me, which is I only have to pay for, I don't know, 100 tokens or 100,000 tokens, write my code for me, test my code is reliable, I know I can do it,
And then I'll use the AI for something else, which I don't need to, do all the time. I don't need to always test. Now I want to have a review activity. I'm going to send a document now to the Teams chat. Give me 1 second. 1 second, attach file. Thank you everyone for waiting patiently. Okay, great. I have a handout I made. Now it's the same thing on it's two parts of this document, but it's the same thing on each side. And basically, I give you a task. This is geared toward software engineers or product or people who deal with generating software, but even if someone is not from that background, probably you can understand. I give you a task, and I want you to write in it basically how relevant is this, like 1 to 5. And I added another column to say, can I just do this like by copy and pasting something into ChatGPT, or do I need to write code to run it? Like for example, if you open the document, you'll see one of them is like finding a relevant block of code in my project. So you can't just tell ChatGPT, find something in my project on my computer, right? You have to give it information, or you have to write code to give the LMM information, or you have to use like GitHub Copilot. So that means, do you need wrapper code or not? Now, there are no right answers to this. It's really just to get you to think. I think it's a very helpful way to review the information before I move to the next section. So maybe everyone will take like 2 minutes now. You can look at this document. You can use like a paper and pencil, or you can use like a note in your computer, like a notepad. And you can see, you could try to think to yourself, which is more relevant, which is are less relevant. Maybe I can share on my screen the document so you can see it also if someone can't open it. Oh, sorry. Are you raising a hand? I'm not so good at Teams.
Hi,
Okay,
David.
yeah.
Yeah, this is Renu. Are you asking us to tell how relevant AI is for these categories that you're showing on the screen? Sorry, please, can you explain?
Yeah. As a nice review, and again, you don't have to submit this. This is just for you. Try to think how relevant is it to use AI? Like for example, how good is AI at debugging my code? Or how good is it at, reading my logs? And
All right.
every one of these
Mm.
things has their own issues.
Thanks, David.
Maybe maybe another like 30 seconds, and then I'll just say like a few things that I had, and everyone can share if they had anything. One second, I'm sorry. I'll share my screen in 1 second. Okay, maybe I'll just go over it. I don't know if anyone wants to talk about anything they thought about in this. I don't have any cool insights they had. No pressure to share. So I'll say for me, I think just like it's much easier to use AI to write front-end code than back-end code, like CSS. It can be really good at, especially Claude is good. ChatGPT is not so good.
And backing code is oftentimes also more fragile or tricky because you have to know a lot about the logic or the system. Refactoring my code is a great example because AI is really good at refactoring, and it's even better at convincing you that it did a good job. So I don't know how many people are software engineers here, but when you're writing code and you're using something like IntelliJ or VS Code or PyCharm or an IDE, so every good IDE has a feature called refactor my code, and it can automatically refactor like a block of code for you, move it, extract it to a method or to sometimes a different file or to a variable or something like that. When the IDE does it perfectly. It does it precisely based on understanding the code and how it runs in your system. When the AI does it, it's a really, really, really smart guess. So whenever you have to refactor something, if you can use your IDE to extract a method, you should always do that. After that, you want to tell the AI to change variables to make it look a little nicer. That's something. To add comments, that's something else. Or to rename it, or to look at it and give an opinion. But when you're refactoring code with AI, you have to realize that it doesn't work like an IDE. It works totally differently. Maybe another cool things, AI is excellent at explaining blocks of code, which can save hours of time if you do it all the time, every single day, many times a day. AI can't really debug so well. AI is very good at generating unit tests, but you have to make sure that the unit test is what you meant, because it could convince you of something and it could have missed very important data that you know, but you didn't give to your LMM. Yeah, I think anything else is more or less, you can think about it. I thought this was a good exercise just to get your mind working a little bit and to give you a break from me talking all the time. Now we're going to go to the next section, which is basically the second half. We're going to talk about natural language processing. We're talking about this because it is very relevant. Like ChatGPT, everything is a part of this, as I said at the beginning. And also, when we'll basically build our own NLP pipeline, and we'll encounter a lot of the issues that anyone has when they integrate AI into their software, just in the lens of NLP. So what is NLP? We have Harry here who wants to talk, and we have the machine here. Harry speaks in words and talks about things, and the machine talks in zeros and ones. And the question is obviously, how can we get the machine to understand the human, which is the question people have had, engineers have had for like 100 years already. So let's give an example sentence, and I'm going to walk through basically what happens in the ChatGPT when it's thinking about it. Now I just want to caveat, I just want to say the condition, I'm going to skip over a lot of steps, and I'm just going to tell you the steps that are relevant to you as someone who you want to use the AI. So I'm not going to go into the black box, understand everything that goes inside of it. I just want to tell you hints and different things inside the black box so that when you want to use the black box, you can know a little bit about what's happening and how you should talk to the black box. So I have a sentence over here. The king and the queen met a wise woman in the castle. So the first thing the AI does is tokenization. It makes it into different tokens. So AI then removes stop words, which is basically a word without a lot of meaning. And then the AI seeks to normalize basically the words into their root words, into like the root word of the word. So basically, in truth, I'll tell you nowadays the machines don't really do this because they save the context and they save the stop words, they save all this information. But the general process is basically I take a sentence and I make it into these tokens, which mean a lot. So as you can see here, a token is about 3/4 of a word. This is the same, more or less, relevant calculation when dealing with costs and tokens of using an LLM, which is interesting. At any rate, I would just say here, notice that this process of lemma, like turn met into meet, it might seem simple, but it's actually very complex. How do you teach the machine that in English, good is the same thing as better, is the same thing as well? Because well can also mean something else. Well can also mean like a pit that you put water in. So a lot of these algorithms, at least traditionally, were written per language. Like English had its machines,
and let's say, Hebrew or Mandarin or Spanish had a different machine. And as a language was closer to English, like Spanish and Italian is closer to English, so the machine did better at doing that. But if it's farther than English, like Arabic, and it works in a totally different direction, and the root words are totally different, so the machine will really fail. So that's an important thing to note in general in AI, although nowadays you can use ChatGPT in a lot of languages. A lot of times, the language is a very key factor here, and it might even be worth it for me to translate to English whatever text I want to teach the machine. Let's talk about word vectors. So in our pipeline, I have this basically group of words in the bottom in the lemma here. Do you guys see my mouse or no?
Yes, we see.
Yeah, okay, fine. Okay, so I just want to know if it's okay. So I have this vector here, which means a group of words, which is like the most meaningful words in the sentence. Now, what do I do with it? The machine still doesn't know what these words mean. So the machine looks at 1 million documents about these words and see where they come up. And the machine generates, with this very fancy algorithm, something called word vectors. I don't want to explain how they do it, because it doesn't matter, but I want to explain what it is. And what does it mean, a word vector? A word vector means there's a very long vector, and each place in the vector, a vector, for anyone, I don't know, the terminology is familiar. A vector means an array, or it means a group of elements in like a list. So a vector here is that every column in this vector, or table, you could even say a little bit, every column here represents a different subject in the world. Like a subject is like a royalty is a subject in the world, or people as a subject, or places as a subject. And the machine, after seeing a lot of resources, can tell you that a king, oh yeah, the king is really relevant to royalty. And the king is also a person. So he'll get like a 90% to be a person, but a king isn't really a place. Now it's more of a king is more relevant to place than, the word thought, because thought is abstract, and a king, you can put him in a place. So we'll give him, let's say, like 20% on that, but a king isn't really a place. And then let's say for like the word man or woman, the machine will give that people a 90% because it really is a person. But for royalty, it's not really royalty, but it could be royalty. So let's give it 40%, let's say. And for a different word, let's say castle. So castle, it is royalty, so that'll get 90%. But it's not a person, so that'll get 20%. But it is a place. A castle is much more of a place than a king is, so it'll give 70%. How the machine does it, again, doesn't matter. And you'll notice, by the way, in my example here, that king and queen, they should have exactly the same value for place, right? They're pretty similar words, but the statistics, since it's, again, as we said originally, everything is statistical, so it's very possible that the very similar word might get a little bit of a different statistic. This number is a very large float, very large double number with a ton of decimal places. It's not just a simple yes or no, because it's based on statistics. A lot of systems use 384 dimensions to this vector, which means 384 topics in the world that these are related to. Some which are more precise use like 560, I think. I don't exactly know how they came up with these numbers. The more dimensions you use, so the slower your machine will work, but theoretically, the more accurate it'll work. That's called a word vector. Why is this cool? A word vector is really cool. These are the word vectors. Why is it really cool? Because let's say you can like map them. Let's say we only have 3 dimensions. You can map them like a vector like this, which even if you can't really visualize how can the sentence be mapped on a vector like this, because this is 3 dimensions and the other one was 384 dimensions. Anyone who learned linear algebra knows that you can use something called cosine similarity, which means like a very easy calculation of, is one vector similar to another vector? So for example, if I have this vector, which is my main vector, king and queen met a wise woman in the castle, and I have 2 other sentences, and I make a vector from them. So I can use this calculation of similarity and see how similar. Like let's say this is 100% similar because this is my base. So this sentence, like the wise queen met a woman, it's really similar because it's the same people meeting the same people, but now not the woman is wise, but the queen is wise. So it'll be, let's say, 80% similar.
And this sentence is not as similar, but a little bit similar. It has to do with a castle and a woman and a king and queen, but all the order is flopped and switched, and therefore you only got like 40% or 50%. Now, these examples are not accurate examples. I'm sure if you put it into a machine, it'll give you different results. But it's a general concept I want to show that basically, once you compute sentences or documents into vectors, so you can play with them mathematically. And that's at the heart of any AI machine. So therefore, now we have word vectors. We could use something called semantic search. What's semantic search? Semantic search means I can search something not by what the word is exactly, but what the word means. So right now, in a very naive system, like in the old Google, if you want to find something about a war, so if you type in the word war, you'll find documents that include the word war. But if you type in the word fight, which is oftentimes used in conjunction with war, you won't necessarily find the same results, the same document you were looking for, which only included war, but didn't include the word fight. So semantic search is basically the ability to search for something, and not just that word, but close words to it, which is used in conjunction. And the way it works, obviously, is doing exactly this, finding vectors which are similar enough in meaning that, oh, the word fight is probably really closely associated with war. So how does it work exactly? How can we use this, our black box, even though it's really gray, our black box of a semantic search engine? This is just an example because it's free and that you can use it in Python, and I've used it before. That's why I took it. It's called Face. How do I use a search? I take all my documents, I put them into my search engine, and here, when this is happening, I'm translating these text into vectors. I put it into my black box until it made vectors for all these things. Once my black box is ready, then on the other side, I can, let's say, get 100 similar documents to, or 10 similar documents to a different sentence. Then it'll give me an output where basically it'll list in order of similarity all sorts of different documents that I put here and how similar they are to my example sentence. That's basically how you use it. Now I have a question. What if I have a corpus? A corpus means a collection of documents. A corpus of like, I don't know, 3 billion documents. I have a lot of things, but they're filtered. Like some of them are from one book, some of them are from a different book. Another one is from a different chapter. How can I filter this? How can I add in metadata to make my machine work? So again, I'm just using the example of face. I'm sure there's other examples, but this is a common and easy example to use. In the case of face, you can use face for free. However, there is no way to filter face, at least as of today. There is no metadata parameters used. You can't do anything. You could just tell it how many documents you want, which is similar to this. So the way to do it, obviously, is to add in a lot. Oops, sorry about that. Is to add in a lot of wrapper code to make a lot of different indexes and to put the different texts according to their metadata into different indexes. And then according to what the user wanted, and at the end is to know how to basically use different face engines into your indexed database of all these face machines. In other words, you need a lot of ketchup to eat this hot dog. You need a lot of wrapper code to know how to make your machine use this AI really effectively. So let's talk about our pipeline so far. We began with a corpus, a huge amount of documents. We made them to tokens. Then we made them into these vectors. We used a search engine like, let's say, Face. And now we can display it on the front end, and we can tell the user, I have 4 billion Wikipedia articles, and you're looking for something specific, so you can give me a few words, and I'll tell you similar sentences. Okay, so that's already really cool. And just think about also how much of the wrapper code you need to connect this whole thing to work. This, in our pipeline terminology, is called pre-processing. This is what I do to the documents before I play with them in my black box. And this is basically post-processing, what I do to my results of the black box before I present them. So I want to talk a little bit about pre-processing, because it is not trivial in our pipeline. Pre-processing. So I have this big corpus, which is my huge amount of documents, and I have my word vector. What are important things for me to consider in my corpus before I make it a word vector? Does anyone have any ideas? What could be something which is important to do to my documents before I try to mathematicize them? I never know if people are listening in these things because everyone is on a different time zone and doing other things. But I'm assuming you guys are listening, or if someone wants to say anything.
So you want to structure the documents, the content of them.
Okay, excellent. You are Roni? Is that it? Okay, so I think Roni said that is that we have to make sure we have to see what the structure of these documents are. So first of all, and someone wants to say something else besides just the structure of them, or to try to define what it means structure. Okay, so I don't want to put people on the spot, so I'll just talk about it. First of all, there's a lot of these character marks, or even like, let's say like emojis, which might be really common in a corpus, like you know, a ton of Twitter tweets or LinkedIn posts or reviews about a product online, which are all very valuable corpuses for companies to dissect. And they have all sorts of these crazy things in them, which ruin the machine's black and white 0 and 1 way to compute them. So you have to strip the text of all these things. You have to understand what language you're speaking in. As we said before, a lot of these machines, if they use a traditional tokenization and lemmatization, they need to understand things in English or the language that they know. And so even if it's a mostly English sentence with like a few Spanish words here and there, that might really corrupt my data here. So I have to make sure I understand exactly what language is my corpus and what language is my black box machine waiting for. I have to also, a lot of times this data is going to be scraped from the internet, and I'll get it as an HTML data or as some sort of other formatting. Like ChatGPT, if you use like their API, I just used one yesterday or 2 days ago, and it gave me it didn't just give me text, it gave me text with like all these asterisks and slashes, like the kind of thing that you have on like the GitHub README, all this like markup things. And I didn't want that. I wanted just the text. So you have to also clean the text of all of these things so it's clean. And another thing I think maybe is what Roni meant, I'm not sure, is that you have to make sure the size of your document is also fitting, meaning it's very possible, again, it depends on how you're going to implement your pipeline, but it's very possible that if you try to give your pipeline documents which are 100 times the size of other documents, it'll be inaccurate. Maybe it'll always think that those documents are relevant, or it'll think that the small ones are relevant. You have to have some sort of validation on the size of your document. So far, if we have this information now, this fits exactly into our pre-processing. Because before we give the information to our black box, we have to make sure it's the right format. Okay, so now we're going to go on to another thing called large language models. And basically, I think a lot of people know a lot about LLMs. I want to now use it effectively in my pipeline over here. So here are 4 large language models. And it's important to know that not everything is the same as ChatGPT. Everybody, first of all, forget about that there's like now like 500 versions of each one of them. There's like ChatGPT 4 or 5 and 6, I don't know, whatever. And Gemini Flash and Gemini Vite, I don't know. Different LLMs have different strengths. Gemini is really good at using huge contexts. You can use like even like 1 million tokens in Gemini. Claude is really good at generating code. It's much better at generating code than I think all the other LLMs, in my experience at least. Meta, I never used one of Meta's, but I read online a lot, and you can really customize to understand your environment. Every LLM has their different pros and cons. You have to understand the choice of what LLM you're going to use is extremely important. It will define the results in very, very large ways. And also each of them have different costs, which we'll get to. I chose my LLM. What kind of parameters do I give to my LLM? So first of all, obviously the main parameter is my prompt. Is what I tell it, just like on ChatGPT, the main thing that as a result is the information you give it. It's important to realize that if I use less words, it doesn't cost as much money. This is the sign for money in Israel. It doesn't cost as much money. If I use more words, then it costs a lot of money. And I always have to understand when I give the prompts, let's say I'm doing an automatic thing in my pipeline, am I ensuring that my prompt is not like accidentally really, really, really long, and it'll also give me a better result and also cost me a lot of money, maybe like 100 times a day. You can define its temperature, which is another very important parameter here, which basically tells the LLM how much to be creative or how much to be very focused and factual and short. Like ChatGPT, I think is somewhere, I think it errs on the side of being creative for the general user, but you can actually edit it even for free in your free version on the UI in their website. I tell it to be very focused and factual. It's a lot easier to do things with coding for that. And another very important parameter here is the max tokens. A lot of times you want to limit the tokens that you're giving to the ChatGPT, but to the LLM, but also how much you're getting back. Like you don't want it, if you tell it bad parameters, like let's say you might tell it to be really, really creative, it might just start rambling on a really, really, really long time. And if you're expecting it to tell you like, JSON data or like a very structured specific type of data, it might make it really long and really extraneous. And so you can tell it, well, no, I only want you to have a certain amount of tokens. This is usually a parameter you can set, but you can also even tell it in the prompt sometimes. Say, give me this value up to 20 tokens, something like that. I just did that 2 days ago because I didn't have time to do with the parameter. I want to talk about just pricing here. A lot of times the pricing is a little bit amorphic. It's a little bit not so clear to us. They tell you something like, it's like a teeny tiny bit of money for like 1,000 tokens. Like, okay, that sounds like a lot, right? So how much is a token? So as we said before, a token is basically a word. It's a less than a word. So if it says like a million words, that's usually 750,000 tokens. I think I did that correctly. These are all different things considering when you're using an LLM. Okay, that's just practical use. Now let's talk about something really cool you could do with an LLM. So an LLM, as you know, you could do a lot of things. And I find when people want to integrate AI, if they don't know a lot about an AI, they only envision the LLM creating for them like a block of text, like ChatGPT does. Like they don't think about, oh, I can get ChatGPT to define something for me and then give me like a value. They just think, oh, ChatGPT will talk about it with me, and then in my pipeline, at the end of my pipeline, I'll get the ChatGPT to give like a summary about it, or I'll get it to like try to get some idea from the user. And you can really tell ChatGPT to really make very structured data, not just ChatGPT only, all these elements to make really structured data in your ecosystem, which is really cool. So I want to use an example of how to use an LLM to make structured data in your ecosystem. There's the term in natural language processing. I'm going to now diverge from that, tell you about this term, and then I'm going to go back to that conversation, and then we'll bring it back to our pipeline. There's a term called named entity recognition, which basically means if I have a block of text, there's all these algorithms that are built to try to extract structured data from this text. Okay, this is until LLMs were not rampant, until they were common. So this was done a lot of different algorithms, something called Spacey, which is a package in Python you can use for free. And basically it extracts these entities, and you can even oftentimes give it some sort of type to extract these entities from this text. In addition, if you want to take something else from this text, which is really cool, you can take these entities that we just created, and you can find also relations between these entities. So like, let's say here I see Microsoft announce an investment in OpenAI. So this entity is related to this entity with this type of relation. And this is something for my database to be able to track it, let's say. I don't know what. So this is a really cool way to basically take your unstructured data, your corpus, your collection of documents, and to make it into a map of data, which could be really cool then. I can then have like, my machine can search by filtering certain things or by seeing Microsoft and seeing all the different people that it invested in. Without me making the LLM work really hard to scan billions of documents to get data or something like that, or even something that like we did with semantic search, we just heard a similar sentence. This is a great way to tell, I want to see everyone that Microsoft invested in. So you have this entity, this passage has to include this entity, and has to include this relationship. Now, I want to bring it back to our LLM discussion before. You can do this the traditional way, which is basically getting a text, and then using something like Spacey, which is a traditional way to get entity relationships. And then after you get all these entities, then you could do something with a prompt. I don't know. You can like summarize this and think about any of these entities over here. This is really important to me. Or you could do something which is really cool, which I'm actually doing a project now using this, where you can give a prompt. You can give your corpus as a prompt, which could potentially be very expensive. You have to weigh, is it worthwhile or not for you? You can give your corpus as a prompt to ChatGPT and say, instead of ChatGPT or an LLM, just easier for me to say ChatGPT, so I say ChatGPT a lot. Instead of ChatGPT giving you just like a summary or highlight or like advice, which is a lot of people think of ChatGPT to do it, ChatGPT, you could tell it, give it to me in the JSON. And ChatGPT will basically compute these entities and relationships for you from your corpus. It'll compute them to you as a JSON. And then your pipeline will just take the information and then maybe like populate a database with that, or create a map with that, or even just display it on the UI in a really cool way. But again, we can use the LLM as part of our pipeline and not just as like the end or the beginning. Now, I want to ask the community here, what do you guys think is like a pro or a con? Like what's like good and bad about getting it by myself with these like very inflexible machines that are built in, and then using ChatGPT to talk about them, or using ChatGPT to actually extract them from my corpus directly? Can anyone think of something good and something bad about each approach? Okay, I don't want to put anyone under pressure, but I think, at least for me personally, when I thought about this, I think that this is free, which is cool, but this is precise. Like this is not something you can't really tell Spacey how to extract information from your corpus. It has its algorithms that it does, and that's what it does. Whereas this is much more precise. You can tell it exactly what you want. ChatGPT is really good at adapting itself to exactly what you want. However, it's extremely expensive potentially because you have to put your whole entire corpus into the LLM, and you can imagine how many tokens your corpus is. If we talked about before that your corpus should be huge, so also your wallet and your budget has to be huge. Here's our pipeline so far. So if we want to integrate our LLM in, we can use it to collect metadata, or maybe to extract NEREs, as we said before, to extract different named entity relationships, and things like that. We can use our LLM then to feed this like JSONifies data into a search engine. Or alternatively, we can feed everything first into the search engine and then get input out and then bring that to our LLM and then use that as, with user input or something like that. So basically there's a lot of different, opportunities here and a lot of different places to put ketchup on, right? Why am I putting ketchup everywhere? Because you see this really cool pipeline, really cool technology that called ChatGPT and Face, which are things that a software engineer probably won't develop. They're things that an AI researcher will develop. They might make a lot of money using these big, ways to do it. But at the end of the day, you need ketchup to wrap everything together, which is basically what a software engineer does. So now I have an activity to do, which is really cool, but I'm supposed to end 5 minutes early, and I want to respect everyone's time, so I think I'm going to do that. But I'll just talk to you about the activity really quickly. What I did was, I made a handout. I just sent it now. You can open it. Now this handout, it looks like it's in Parsi and Hebrew, but it's not. It's just some of the information is in Hebrew, which is part of the point. And basically what I did here in this handout, unfortunately the document got a little splattered here with the pages, but yeah, okay, whatever. Basically what I did is I gave a mission, which is to create a search engine for a Talmud, which is a book in Jewish text, which is a very, very logical, interesting book, which a lot of cool data in it. And you can use Face unlimited because it's free, but you can only have limited LMM. And what you have to do is basically, you have your corpus, which looks like this. You have these API calls, which will give you this information. As you can see, the text has all these different markups in it. You have a little bit of metadata in it. Part of the metadata is in Hebrew, part of it is in English. This is what it looks like if you render this text. You can see in this word, this is clearly English text, but there's a lot of these things in italics, which are these weird Hebrew words, but in English text. And the idea was, you have to think about
how your user input in, how do you pre-process this, and how do you out-process it, how do you post-process, and how do you basically make a pipeline with this text. I think it's a really cool exercise if you spend 5 minutes on it, and you can try to review the whole entire presentation and make your own pipeline, but the time is up. So I want to say thank you everyone for watching and for being, I guess, a good audience. I hope this was interesting to you. And if everyone wants to do me a favor, you can write me like 1 sentence of feedback. You can do it privately if you want, if it's good or bad feedback, something that maybe you expected and you didn't get in this presentation, or something you thought was really cool. I don't know. Oh, I see people are clapping. Okay, that's really cool. Thank you so much for listening, everyone. I'm happy to continue the conversation if you want in Teams. Have a great day, and may this help us further make the world better and contribute to society. Okay. Have a great winter, everyone. Bye-bye. I'm going to end the meeting because I want people to feel comfortable to leave. So I'm going to vary about the end of the meeting. Bye-bye.
Thank you.